This method can help to answer key questions in the field of bicyclic aziridinium ion chemistry for the synthesis of various aza heterocycles including piperidine and azepane ring systems. The main advantage of this technique is that the synthesis of chiral piperidines and azepane core present in various natural products is achieved in a straightforward manner.
First, add 100 milligrams of the alcohol, 140 microliters of triethylamine, and a magnetic stir bar into an oven-dried 25 milliliter 2-neck round-bottom flask under nitrogen atmosphere. Using an airtight syringe, add 5 milliliters of anhydrous dichloromethane to the reaction flask. Cool the reaction mixture to 0 degrees Celsius using an ice water bath and stir the mixture for 5 minutes. Next, add 164 milligrams of p-toluene sulfonic anhydride to the reaction mixture and stir for another 45 minutes. After stirring for 45 minutes, warm the reaction mixture to room temperature and stir for 30 minutes. Monitor the reaction progress by thin layer chromatography using hexanes and ethyl acetate as the eluent. After the complete consumption of the starting alcohol, quench the reaction mixture with 5 milliliters of water. Then extract the heterogeneous mixture 3 times with 15 milliliters of dichloromethane. Dry the combined organic layer over anhydrous sodium sulfate for 10 minutes. After